Exponentials and logarithms are inverse functions. So we're going to learn a couple properties about relating logs and exponentials. The first one is how do you exchange between the two different forms. You can see that exponential form is b to the y is equal to x, but an equivalent form of that is where we now introduce the logarithms. The log base b of x is equal to y. Now notice how you exchange between these two forms. B is the base in both of them, and you're going to be switching the x and the y. So b to the y is equal to x. Notice that logarithmic equations are always equal to exponents. So whenever you're talking about a log, you're really talking about an exponent. And that makes sense here because look at the exponent on that base. Knowing how to go from one form to the other one can save you a lot of time. It's a very powerful property. Also, if you think about these properties, they should make sense. B to what exponent equals 1? B to the 0. B to the first equals b. B to the x equals x. And this gets a little bit trickier, but notice what's happening. You're taking an exponent and a log of x. And when you think about logs and exponents, they're inversely related, they're inverses, and you're doing something and undoing it. And therefore, that's why you end up with the original x in both of those cases. I want to go through a couple examples by applying those properties. And the first example we're going to think about is going to be 7 to what exponent is equal to 7? And you're going to see that that is going to equal 1. Here's a 10 to the log of 5x. When there is not a base here, it's assumed that it's a common log, has base 10. So this is the inverse functions. It's a composite of inverse functions. So you're going to go 10 to the log of the base 10 of 5x, which means you're doing something and undoing it, so you're left with 5x. This is going to have log base 2 of 2 on the exponent. You can see that 2 to the 1 power is equal to 2. So we can rewrite that as 1, and so that's just going to be equal to 3. On this one, 6 to what power equals 36, and you can see that that's going to be equal to 2. 3 to what power equals 1 over 81, a little trickier here. And what you want to do is get 3 as a base on this side. So it's going to be 3 to the negative 4th is equal to 1 over 81, and therefore your answer is now negative 4. These are inverses, so composite of inverses is equal to what you started with. Here is a story problem, and you're looking for the keyword, which is compounding continuously. So that's A is equal to PE to the RT, and your 3,000 is the initial, 6,000 is the finishing. So that's going to say that you're basically doubling your money. Your rate is 0.06, and the time is question mark. So you're going to divide by 3,000 first, and now what you're going to do is do the logs. Change it to a log form so you can drop that t down to the main level. You could take the log of both sides, or you could just convert between the forms. So you could say ln, that's the natural log, ln base e of 2 is equal to 0.06 t. And therefore, that means that this is equal to 2 is equal to 0.06 t, and t is equal to 2 divided by 0.06. The other way you could think about that is actually taking the ln of both sides, and if you did that, you would get something like this, and therefore ln of 2 is equal to, this is where you're really doing the inverses again, so you end up with the exponent, which is 0.06t, and you can see that that's going to be the same thing as this step here. So you could change it around by the property, or you could take the ln of both sides and then do the division. So one other thing at the end here that you should know, common log is going to be log of base 10, and the natural log is going to be log base e. There are some properties on logs and how to use them solving expressions or simplifying expressions, as well as solving story problems.